Welcome back. Our next video for MISY 330 is on entity relationship modeling. These concepts that we're going to cover today are going to be absolutely critical for the rest of the semester, whether we're doing logical data modeling in a little bit. Logical data modeling will follow logically from this. But then even when we get into later in the semester, when we look at SQL, you'll need to have a working knowledge of entity relationship modeling. So it's going to be an absolutely critical thing for you to learn. So let's get into it. In the first video of the semester, I thought I'd review a little bit here of what we talked about last time. Last time we talked about the ropes model and how the presentations are going to be structured this semester. I also talked about what is, and I introduced the relational model itself. Very important concept we're going to be talking about all semester. The three components of the relational model, we talked about things like how are relational data structured, how relational data ensure data integrity, how relational data are queried, and I showed you an example of SQL, although we didn't go into it much, but we will later in the semester. I talked about the disadvantages of the relational model, and so today we're going to dive into entity relationship modeling, which is going to be absolutely critical. So in terms of an overview, the O in ropes, today we're going to cover what are business rules, what are the components of an ER diagram, what are maximum and minimum cardinalities, and then we're going to look at how to draw ER diagrams using Visio 2010. So one of the things we want to talk about today are what are business rules. Business rules are the rules, at least with regards to data, that govern an organization. These are extremely important, and it's important to understand that different businesses might have different business rules. They're assumptions. You may not agree with them. They may be something that's inconsistent with your experience. But at the same time, if it's the way a company runs things, then that's the way it is. What we're trying to do is not model your reality. We're trying to model the company's reality. And so it's important to keep that in mind. So when I go through these examples, I'm going to show you some examples here in just a minute, I want you to understand that you may disagree with what I come up with, and that's okay. This goes under what we're going to call it depends in the database class, because it really doesn't matter whether we think it's right or wrong. It really depends on whether or not the customer thinks it's right or wrong, because we're trying to model what that customer is doing. So it's very important to remember. So let's go through an example here. We have a customer and we have an order. Now, within ER models, and we're going to be getting now into the components, which is our second item on our agenda for today. The components of an ER model are pretty simple. They're the boxes, which are going to represent data, or the entities. That is the logical grouping of data that we're trying to model. Now, this is at a much higher level than a spreadsheet. So customer here could refer to the customer's name, the customer's last name, the customer's first name, the customer's address, customer's postal code, a lot of different things that this could actually refer to. But it's very helpful in ER models to be able to see the data on a higher level. And that's one of the advantages of ER models. Same thing with order. Order here could refer to the order number or the order date. So we want to model the interaction between these two, and that's done through a relationship or a line. So I'm going to choose the connector here. And by the way, at the end, I'm going to start you from scratch here so you can see how to do this. But right now, we want to just focus on how to do ER models. So I'm going to connect these two to indicate that there's a relationship between them. Now, don't worry about the line here. We're not going to actually use that in this particular arrow here. So what we want to do is right-click, go to Format, Line. And so what we're going to do here is change what it looks like. First of all, we want to change the weight a little bit. I personally like 2 1/4 point. I think it looks a little bit better. The begin line. So we have to decide what our cardinalities are. And I'm going to explain this in just a minute. But let's assume now, for the purposes of this particular model, that a customer can place 0 to many orders. Again, you might disagree with it, but let's just go with that. So a customer can place 0 to many orders. So this is the end right here of the line. So we're going to pull this down, and if you go down into the high 20s, you'll see that this little crow's foot here with a circle on it indicates 0 to many. If we go the other way, an order can be placed by how many customers? Well, let's assume that our orders can only be placed by one customer, but they have to be placed by at least one. So once we get that done and we choose it, now you're going to see a completed ER model, at least with only two entities. So let's read it again. A customer can place, and as a matter of fact, let's actually double click this and let's put places. And so now we have the name of our relationship. So we have a customer places. See if I can increase that maybe just a bit so we can see it a little better. There we go. So a customer places 0 to many orders. Now what that means is that a customer doesn't have to place an order. It's what's called an optional relationship, because right here we're indicating with a 0 that a customer doesn't have to place an order, but they can. And if they do place orders, they can place many orders. So there's two parts to a cardinality. There's the minimum cardinality, which is the 0 here, and then there's the maximum cardinality, which means at most. So the minimum means at least, and the maximum cardinality means at most. So at minimum, a customer could place 0 orders, but at most, a customer could place many orders, which I think makes sense. Now going the other way, when we read it right to left, what this indicates is that an order can have at minimum one customer, that's the first one there on the right side, and at most an order can have one customer. Now what that means is, of course, is that an order has to have one customer, period. No ifs, ands, or buts. Now because the minimum cardinality here is a 1, this means it's a mandatory relationship. An order must have a customer. No ways around it. But a customer doesn't have to place an order. So hopefully that makes some sense. So let's go through and do some more here. From your experiences, let's look at book and author. A book can have probably many authors. You've seen co-written books before. So a book can probably have many authors. And a book probably has to have an author. Going right to left, an author, well, can they write many books? Well, sure. So we have a situation where a book has to have an author, and it can also have many authors. But going the other way, an author can write many books. The question then becomes whether or not an author has to write a book. Well, since it's an author, let's say, sure, they have to write a book. So if I double click on this, okay, we'll put our names in there. Let me up that a little bit so we can see it a little better. And then let's play with the cardinalities. Format, line. Move this out of the way so we can see it. Now the end is going to be, remember we said a book is written by, and we said it's got to be written by somebody. So we're going to say 1 to many authors. Going the other way, an author can write 1 to many books. And so when we do that, let me go back down here and choose the right one. There we go. We'll say OK. And I didn't up let me change the weight on that line a little bit so we can see that a little bit better. And we'll make it 2 1/4. There we go. Good. So let's talk a little bit about painting and sale. A painting can, let's say a painting, let's go the other way, let's read it the other way, because sometimes a painting is contained by a sale or a sale contains a painting. So let's say a painting is contained by a sale. That doesn't really kind of work. So let's say a sale contains a painting. So in this situation, we're going to actually read this right to left. So we want to indicate that in our line so there isn't any ambiguity. We don't want to say a painting contains a sale. That doesn't make any sense. So what I suggest when doing this is that we put a less than symbol there and we put contains. And what this allows us to do is to indicate that we read this right to left, not left to right. It's something, it's just something that I came up with because it's a little bit easier to see. And so let's go in here and do our model here. Let's keep it over here so you can see it. And a little bit tight on screen space here. So let's, since I forgot to do that last time, let's up this to 2 1/4 point. So let's say a painting. Well, can a painting be on many sales? Well, a painting is a unique thing. If we assume that a painting is a one-time thing or something absolutely unique, a painting can only really be on one sale. So let's make that change. Now again, you may disagree with this, and there are some exceptions to this, but for right now, this is going to be modeling my reality. Now, a painting may not have been sold yet, so we're going to say that a painting can be on 0 to many sales. Going the other way around, a sale can contain, well, I suppose a sale could contain many paintings, but since a sale is such a very big deal, and similar to like buying a car, when you're buying a painting, let's assume that each sale is unique and that a painting, each sale can only have one painting. So the sale can have one painting. And let's also say that, let me find my right cardinality here. There we go. And let's also say that a sale doesn't have to contain a painting. Maybe it could contain something else. So this is what our model looks like now. Let me fix that so it's connected. There we go. So what we're saying is a painting can be on 0 to, I think I said that was going to be 1. So let me change that. I chose the wrong one here. There we go. So a painting can be on 0 to 1 sales, or a sale can be on 0 to 1 paintings, or can contain 0 to 1 painting. So again, this may not make a lot of sense to you for right now because this particular one seems a little quirky, but again, I want to illustrate that some business rules can be quirky. I mean, they are actually, in some cases, a little quirky because it really depends on how an organization does things. So if an organization does things differently, then that could be the reality. So I'm going to change that just so it's a little bit different there. There we go. We'll do this one. There we go. Okay, so let's go to one that's maybe a little bit more obvious, and that is car and owner. Now let's assume that we're not just tracking only the current owner, but the history of all people who own a particular car. When you add the dimension of time, that usually complicates things from a cardinality perspective. So let's get in, let's change our line here. And again, we want to model the history of this. So in that situation, if you think about it, a car could actually have many owners. And a car could be sitting on a lot, so a car might not have any owner. So in this situation, we're going to say 0 to many. That is, a car could have 0 to many owners because we're going to track that same car through the different owners that it has. Now we go the other direction, an owner, well, I guess if you're rich, could have many cars. And of course, since he's an owner, let's assume that he has to have a car. So in that situation, we have a 1 to many. Now again, when you're looking at this, you may be scratching your head and saying, that's not my perception of reality. But at the same time, it's important to remember that this can happen. So I'm going to get back to this in just a minute. I'm going to close out Visio because I want to show you. I'm going to go ahead and save no, I want to save those. I'm going to go back into Visio. Now on my particular machine, again, this may not be the same way your machine is set up, but in the lab, you want to be looking for Visio 2010. So if we go here, and it's going to be under Microsoft Office, of course, and we're looking for Visio 2010. I do want to caution you that Visio 2013 changed dramatically. There's quite a bit of differences in the interface. You're free to use it if you'd like to, but the interface will differ quite a bit. Visio 2010 and 2007 are pretty consistent. So when I choose that, by the way, there are specific, what do you call templates, I guess you'd use the word for, database. But the problem is that, and here's one of them right here, this database model diagram. Don't use it. The reason is that there are certain things that will not allow you, for example, to draw relationships with many-to-many relationships. We'll talk about that in class as to why that is. But I think it's a lot simpler just to use the basic diagram within Visio. So if you choose basic diagram, and it'll create it, from there you can just simply drag in from the template, the basic shapes template. You can use squares. I think actually I used rectangles actually when I was drawing mine. And then it becomes very easy. You draw that in like this, and then you use the connector tool to connect them and do it the way that I showed you. If you do it that way, it's a lot easier. You can actually then model many-to-many relationships, and that is something you're definitely going to want to do at the beginning of the semester. And we'll talk about why that can be, why they put that restriction on it, but we'll hold that off for class. So let me go back to the models that I just developed. And this really is the conclusion of the presentation part, and that's going to take us actually into the exercise. And so what you're going to be doing is part of the exercise. What I'd like you to do for class is I'd like you to come up with the business rules for the last two here: car and parking spot, and student and section. So I want you to come up with a relationship between here. Now, as we talked about, yours may differ from mine, and you may differ from the other person in the class. What's important is that you understand why that particular relationship it makes sense to you. It isn't that it has to be right or wrong, but it has to be consistent with your thinking in terms of what you think the reality is, because that's what we're going to be doing, is modeling a particular reality. So have that ready for class, and that should help you on the quiz. All right. Well, you don't see a presentation slide here, or I'm sorry, an exercise slide, because the exercise was integrated into the presentation this time. But we did, again, cover a lot of ground, and this presentation is going to be absolutely critical for you this semester. We covered what are business rules. Business rules are going to be something they're going to become very natural to you, but they do take a little practice. We talked about the components of an ER diagram, basically the E being the entities and the lines of the R being the relationships. And then we labeled the relationships with cardinalities as well as a verb to indicate how the entities interact. And then lastly, we dove down a little bit into what are maximum and minimum cardinalities, so you have an understanding. Minimum cardinalities indicate whether or not a relationship is optional with a 0 or mandatory with a line. And the maximum cardinalities indicate whether it's either one or many. So I hope that helped. Take care, and I'll look forward to seeing you in class.